Okay, the first thing I'm going to do is on my little diagram I made here, I'm going to not label that with blue. That's wrong color. I'm going to put 0 degrees, 180, and 360. 0 and 360 are coterminal. They're in the same spot. And so if this is 180, then that means that this is 270. I'm not going to label it. I'm just going to know that it's 270, and I'm not going to label it for a reason, but it's up to you. And so 285 will be a little bit past that, like here-ish. Does that make sense to everybody right there? My location of 285. Okay, and then it says find the reference angle. The reference angle is this angle right here. And I say, okay, what's the difference between 285 and 360? So up here, I'm going to go 360 minus 285, which is 75 degrees. Okay, now I'm going to find the other three quadrants. In this particular picture, I'm not going to draw the whole bow tie. I'm just going to draw the other arrows just so that my picture doesn't get too complicated. Okay, so in quadrant one, my angle is the reference angle, 75 degrees. In quadrant two, my angle is 180 minus the reference angle, which is 105. In quadrant three, it's 180 plus the reference angle, which is 255. And I don't need to find quadrant four because that was my original angle. It's already in quadrant four. Okay. A positive coterminal angle to 285 is 285 plus 360, which is 645. And a negative coterminal angle is 285 minus 360, which is negative 75. And I'm hoping at least a couple people in the room said to themselves, oh yeah, that is at negative 75. Because I went backwards 75. Does anyone have any questions about that problem before we move on? Anything you want to ask me at all? Are you sure? Okay. All right. So now scroll down to number 11 and number 13. And we are reviewing something from Math 1 here that is in chapter 10. Chapter 10 has sequences in it. And it assumes that you remember everything from Math 1 sequences. Do you remember every single possible thing from Math 1 sequences? Not even one thing. Okay, that's why, and I don't blame you because we're doing it right. Well, actually, we did it last chapter in Math 1, so that would have been 2 years and a couple months ago. And your book, CP/M, as great as they are, assumes that you have retained everything like a computer. So I don't think that way. So we're going to go over what you need to know to be successful in chapter 10 sequences. Okay, first, let's do the stuff that's easy. What is this particular thing changing by? What's the growth here? Yes, -20. And so the letter that we use for that is D for common difference. You might think of it as slope, but D equals -20. Okay, now what I want you to do is draw an arrow backwards, and this is going to start to come back to you in a second. What number would come in front of -16 in this sequence? 4. Okay, let me explain what I did. I went down 20, down 20, down 20. Oh, to go backwards, I have to go up 20. Okay, and this is called term 0 or T0. And this would also be called B. So mx plus b, basically. So we write our equation T of n equals -20n plus 4. I want you to think of this as f of x equals mx plus b. Does that make sense? Growth times x plus start. But start in sequences is the number before. Okay, and then when it says find A37, for us, for our book, we say find term number 37, and we're going to plug 37 into here. I forgot the equals. What the heck? Like they did this in Math 1? Yep. Okay, last question for this problem. Does anybody know? I'm hoping I have just kind of reminded you, like opened up a little like dusty file in your brain. Does anybody remember what type of sequence this is? Arithmetic. Nice. And arithmetic means linear. So that's where that mx plus b comes in. That was impressive. Nice, nice. You knew what I was going to ask next. Okay, so let's apply this knowledge to number 13. What is the growth in number 13? What's happening in that one? Multiplying by -2. So I'm going to put times -2 right here. And in a multiplication type of sequence, we call that R for common ratio. So growth is R for this. Okay, here's a little bit harder question. What number would be in front of the sequence? 1.5, great. Positive 1.5. And we still call that term 0, so term 0 equals positive 1.5. Okay, now you guys already said it, but this type is geometric because it's multiplying by the same thing each time. And the format is exponential, yes, which is t of n equals a b to the x. So term 0 times r to the n. So f of x equals a b to the x. And then we plug in, we want term 12. And I just did this on the calculator, 6,144. Okay, we're going to come back and do these two later, like much later in the chapter, so I can remind you how to do this again before we get to chapter 10. Because when we get to chapter 10, they're going to expect you to know how to do this. It's in there. It's in your brain in there. It's just really dusty. You guys ever watch the SpongeBob episode where he's like going through the files in his brain and he's like dusting them off? No, no, nobody. You guys all had good parents, so they wouldn't let you watch SpongeBob. But me, my kids, we plopped down in front of SpongeBob with the sugariest cereals you could find, full of like red dye number 40. Yeah, I was the kind of parent I was. At least I was sitting with them. I didn't just like abandon them in front of SpongeBob. I also really like SpongeBob, so cool. Okay. All right. Your question is, are we doing any resource pages in here today? I don't think so. So you guys can just, actually, what I'd like to do next is have you look at the mid-chapter review and see if you have any questions for me, if you got stuck on anything. This is 15, sure. So this is the worksheet that you guys are working on. Look at number 15. Just gonna draw some axes so I can draw my triangle, and also helps me think about what quadrant I should be in. Okay, now when you guys are doing Pythagorean identity problems for a little while we're getting used to it, I want you to take cosine and write an x, and I want you to take sine and write a y. Just at first, while you're getting used to Pythagorean identity problems. I want you to take cosine and write an x next to it, and take sine and write a y next to it. Okay, and then let's decipher what this is saying so that you can pick the quadrant correctly. So this is saying x is negative and y is greater than 0, so y is positive. Okay, so it looks something like this. You have a negative, positive for your XY coordinate, negative, positive. Does that make sense to everybody how I deciphered this? Let me do it again. If X is a negative and Y is a positive. Okay, what quadrant would X be negative and Y be positive? Quadrant 2. Great. Okay, so you come over here. You just draw a triangle in quadrant 2, just a generic triangle. It doesn't have to be any specific, but it does have to be the piece of the bow tie. So that is the piece of the bow tie that would be in quadrant 2. Does that make sense about what I'm saying about the bow tie? Okay, now this says cosine x is negative 3/5, so that's going to go on the x. And sine is what we're solving for, so that's going to go on the y. I'm going to put a y there. And you can put a y here. It's saying find the sine, which is y, and then put a 1 on the hypotenuse. Okay. Negative 3/5 squared plus y squared equals 1 squared. Nine over 25 plus y squared equals 1. Okay, let me pause there. Everybody okay so far? You see where I got the 9 over 25 from? You see that it's positive. Okay, now I'm going to say 9 over 25 plus y squared equals 25 over 25. Y squared is 16 over 25. Square root y equals, okay. So this is really important to me. When you square root both sides, there should be a plus or minus. And then the square root of 16 is 4, and the square root of 25 is 5. Okay, however, then you have to decide, is my answer the positive one or the negative one for this quadrant? If it's going up, right, that means that sign is positive, so you want to choose the positive one. Do you see where I made that choice? Okay, so then your final answer is sine of theta is the positive one. So it's important to me that you guys show your plus or minus here and then choose the proper one for your quadrant for your final answer.
Thank you.
Mhm. Okay, and then give 16 a go, because I think that one you have to, there's a square root involved. Yes, and
Can you go over?
yeah, what is, I don't even know what knife is. Oh, it's the wording. Okay. So 0 mult 2 means there's a double at 0. So this means 0 occurs twice and then 4. So you're going to say y equals, and technically there should be an a here, but these problems are not solving for a problems, so we're not doing that. So 0 mult 2 means x squared and then x minus 4. And then you just have to distribute. Yeah, so whenever you guys see that CUDA thing, their word for double or triple is multiplicity. So it's saying 0 occurs twice. Yes,
Why can't they just put zero never?
I don't know. They're special. Um, we were just complaining about CUDA earlier today because you can't duplicate problems either. So if I make like a whole custom question, I have to go in and copy and paste every little piece of it into a new question. You can't just like duplicate it. I know. I really want to send them a strongly worded email, but you know, I'll just complain to you instead. So like these down here, these don't exist on CUDA. Miss Rice and I made those. Like those are custom. So that's why it looks like how you would expect it to look, because we like literally had to like full on type it all in there. Anyway, but look at us go on our CUDA abilities. Okay, can you guys grab your notebook now? Hopefully I got you unstuck on some things there. And I'm just gonna say, I love you and good luck. Okay, so it's a big day. We're talking about radians today, and after today, you're going to be responsible for knowing which mode of the calculator you need to be in. So it's a kind of a big deal. I want to define what a radian is for you so that you know what you're doing before I just go to the like straight up math of it. But okay. And you guys, this is going to be fun for you. You get to see me struggle. It's going to be great. The first thing I want to do is draw in the radius of my circle. I'm going to draw the radius in at 0 degrees. I want to start by relating this to degrees because that's something that we all sort of have an idea about. Does everybody understand that halfway around the circle is 180 degrees and all the way around the circle is 360? Okay, so what I'm going to do first, and you guys don't really need to do this the same as me. What I'm going to do is kind of picture where 1 degree is. 1 degree is literally here. This is going to be super hard to draw. So if you want to, you can kind of exaggerate it on your picture. And just sort of estimate it, make it look kind of like mine. It doesn't have to be perfectly 1 degree. But I want you guys to imagine the circle broken up into 360 equal pieces. Oh, heck no. Oh, heck no. This is just for, I want you to see the difference between a degree and a radian. Okay, so we can all visualize there's 360 of those little dudes around the circle. Again, that's the only degree we're going to draw. I am going to label that the radius. Okay, what is a radian? A radian is a radius. So what I'm going to do is I'm going to take this piece of yarn that I cut before you guys got here to hopefully be the length of the radius. How precise do you think I was? I was pretty decent, right? Okay, and what I'm going to do is I used yarn on purpose. I'm going to attempt to bend this yarn around my circle to show how much a radian is. This is about 1 radian. Okay, what I want you guys to do is just kind of eyeball it where my spot is right here. So I'm going to go like this, about right there. So that is about 1 radian. My goal right now is for you to see that 1 radian is a lot bigger than 1 degree. Can you guys see that a lot of degrees fit into a radian? Okay, so if I say 360 radians, that's a lot bigger situation than 360 degrees. This is like feet. This is like inches, basically. Except for, unfortunately, radians, it just doesn't go perfectly into there. It's not 12. It's not satisfying. Dang it. Okay, let's keep going around the circle. So I'm gonna keep going. La di da di da di da di da. Okay. So that's about 2 radians. And la di da di da di da. That's about 3 radians, except that's halfway. What number do you know in life that's really, really interesting, that never ends and never repeats and is just a little bit over 3? Pi. This is pi radians. Pi radians is equal to 180 degrees. That's the unit conversion we're going to use through the whole year. Pi equals 180. Okay, well, let's keep going. So I'm going to put my little yarn guy up to 3. This is about 4 radians. This is about 5 radians. This is about 6. Okay, and a little bit more than 6 is 2 pi radians. Okay. This is going to be really hard for your brain because maybe not. I like to think of eating pie. I'm at Nations, right? And if they give me a pie, that's a whole big circle of deliciousness, correct? But on a circle, only halfway is pie. So if you eat pie of a pie, you're only going to eat half of the pie. So you just have to remember, pie is not all the way around, it's halfway around. Okay. And the last thing I want to do right here is just to remind you, radian equals radius angle. That's where the word radian comes from. It's the angle that you get when you put the radius of the circle along the edge. And I asked Chad this morning, do you guys know who Chad is? Everyone has a Chad. I named my ChatGPT Chad. I asked Chad this morning, I said, good morning, Chad. Why do we need 2 different units of measurement of angles? Because it's really confusing. Everybody loves degrees. Why do we need radians? Well, Chad said very smartly, as I should have known, degrees are used for nautical and construction purposes. Radians are used for mathematics because it's based on the radius of the circle. You need to know how many radians because of the size of your circle and your circle radius, which is actually really interesting. So in math, you use radians, except that first we teach you degrees for some reason. Good old Chad. Anyway, you have to imagine Chad's a frat boy now because I said his name was Chad. So, I encourage you to name your ChatGPT. My stepson's is named Bernard. Okay, that was number 60. Now we're going to do number 61. Oh, you can do 61 and 62. And then in number 62 and 63, we're going to do some stoichiometry, which is your favorite. Oh, how you love it. It's unit conversion, like chemistry from moles to. Oh. The good news about this kind of conversion is there's only one conversion factor. So you just multiply by the same thing every time. You don't have to look on a chart to figure it out. Okay. Here's a fun question for number 61. Does anybody remember the circumference of a circle formula? Both of you are right. They're both correct. 2 pi r or pi d, either one of those two. I'm going to use 2 pi r in this case just because I said that the radius was 1, so I want to be able to plug that in. So 2 pi r. So this is just the circumference of a circle formula. Circumference is 2 pi r. And if we assume that the radius of the circle is 1 because we're working with the unit circle, plug in 1 for the radius, which is 2 pi. So C equals 2 pi. I'm really hoping that this helps you remember that to go all the way around the circle is 2 pi, not pi. So if you think to yourself, 2 pi r, the radius is 1, so 2 pi 1 is 2 pi. Okay, now we're going to get into the conversion bit. And what I want you to do up here is make your conversion box. So we're going to say pi radians equals 180 degrees. So this is going to be the conversion that we use every time. All of our conversions are going to have the same conversion factor, which is going to be great. Just throw a box around it so you can see it easily. Okay, here's the stoichiometry bit. You start with the angle that you're given, put times line. In chemistry, do they have you draw the like vertical bars on there? I'm not going to do that here because there's only one thing to multiply by. It's simple, but you can if you want to. Okay, but here's the big question. I start with degrees on top. Should I put degrees or radians on the bottom? Degrees, right. Okay, and what I want you to do is if you have a different color pen on you, cancel out the degree symbols. It's really helpful to remember that you need to have the same units on the top and bottom to cancel them out. Okay. Keep in mind that I'm going to be asking you to convert these with no calculator. So I want to make sure we talk about reducing with no calculator. The first thing I'm going to do is just write 50 pi over 180. So I'm literally just going to multiply the 50 times the top. And then I'm going to reduce by a factor of 10. So cross out the zeros. Okay, so 50 degrees is at the same spot as 5 pi over 18. Okay, let's get back on the wagon and go again. 200 degrees times line. Okay, degrees is on the top, so I want degrees to be on the bottom. Degrees is on the top, so I want degrees to be on the bottom. And pi radians is 180 degrees. I'm going to come back along with my pen and cancel out the degrees. This gives me 200 pi over 180. I'm going to reduce this in 2 steps because my really mean math teacher won't let me use a calculator. So I'm going to go, okay, first thing I'm going to do is reduce by a power of 10 by canceling out the zeros. And then I say to myself, oh, those are both even numbers. So I'm going to divide them both by 2. And got 10 pi over 9. So 200 degrees is in the same spot as 10 pi over 9 on the circle. Okay, one more. 640 degrees times line degrees on the bottom, radians on the top. Cancel out my degrees. Okay, now I wrote it again. I'm going to reduce by a power or a factor of 10 because they both have zeros. 64 pi over 18. And then I say to myself, okay, self, those are both even numbers. So this is 32 pi over 9. So 640 degrees is in the same spot as 32 pi over 9 on my circle. Okay. Get yourself situated. Then we're going to do number 63, which is going backwards. We're going to go radians to degrees, which is actually more helpful for you if you want to draw your stuff in degrees and you're given radians. You can convert it to degrees and then it'll make more sense. I'm just going to give you a bit of a just mental heads up. The setup for number 64 is a lot. The problem number 64 is going to take you longer to write down than, I mean, like a lot longer to write down than it will be to actually do the problem. So much so that you're going to be irritated. Just, mentally preparing you for how irritated you're going to be with number 64. Okay. Conversions from radians to degrees. Okay, so they gave me pi over 2 radians. I'm going to start with pi over 2. This one is a fraction. So I'm going to put times line my fraction bar. I'm going to line it up with the fraction bar on this side. Everybody okay with that? Okay, I have radians on the top. So should I put radians on the top or bottom? Bottom, okay. And I'm going to use the same conversion that I used before. Pi and 180. Okay, and the pi's cancel. And then this is 180 degrees divided by 2 equals 90 degrees. And if you think about that, it should make sense that if pi is halfway around the circle, that pi over 2 would be 1/4 of the way around the circle. Okay, 3 pi radians. 3 pi times line. I have radians on the top, so I want to put radians on the bottom to cancel. And pi radians is 180 degrees. Cancel out the pi's. And I have 3 times 180 degrees. Okay, now hold on and pause here. If you're taking a quiz without a calculator, are you prepared to do 3 times 180? Okay, let me give you two options. Your two options are this: 180 times 3. You could add 183 times if you wanted to, or you could do 180 times 3 like this. So 0 times 3 is 0. 8 times 3 is 24. 1 times 3 is 3, plus 2 is 5. Does this look familiar to anybody? Or what you could do, a lot of my students will do this. Do you see what I did there? So I took the 3 and put it on the side, and then I broke the 180 up into 2 pieces. So 3 times 100 is 300. 3 times 80 is 240. Add those together to get 540. Which way did you guys learn? First one? The second one's not bad in a pinch. If you need it. Yeah, I know it's kind of annoying. Or you could just go 180 plus 180 plus 180. Or what you could do is 18 plus 18 plus 18 and then add a 0. I'm giving you all the options here. Just make sure that you're practicing that as you go. Okay, so 9 radians. This one's going to be weird. You might have stopped here if you had like momentum and you were just doing this yourself. You might have just come to a screeching halt right there. Okay, so this is 9 radians. I'm going to put the word rad there, or radians, just because I need to cancel out the units. Okay, now I have radians on the top and radians on the bottom. And this is 9 times 180 over pi. This is not going to have a nice whole number answer, is the thing. You're not going to be able to get a pretty answer like you did for these two. 9 radians, if you think about it. So back here, if you guys look with me real quick, we could sort of estimate it. So this was 6, 7, 8, 9. It's going to be like over here-ish. What you do is you go to your friend, and I'm not going to put one like this on your quiz, I promise. And you go 9 times 180 divided by, and then the pi button is right above your exponent button, which is the caret. So go second exponent. So 9 times 180 divided by pi is 515.7 degrees. So if you've got a whole number for your radians, you're going to have a decimal for your degrees for sure, because they don't line up nice, unfortunately. Again, I promise I would not give you one of those on a quiz without a calculator. On a test, I might because you have a calculator. On a quiz, no, that would be jerky. Remember how I said that you were going to be irritational with number 64? So sorry. After writing this problem down, you're going to appreciate your packet. After you got this set up, make sure that you grab a calculator. If you don't have one out, pull one out and see if you can put the mode into radians. I need to teach you it's an extremely useful skill. This skill is going to make you successful in this class and in this topic in pre-calc. You can't let go of this skill. Okay, are you ready? And I'm not joking. Like, I'm gonna sound condescending here, and I do not mean to be at all. Like, this is just, it's really important. Okay, are you ready? This is, I'm truly not meaning to sound condescending. I promise you, it's super important. Okay, look at your paper or up here either way. 1 pi over 4. 2 pi over 4. See what I did there? Yeah, you get it? 2 over 4 reduces to 1/2. Okay, 3 pi over 4. 4 pi over 4. Pick it up, I'm laying down. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. I know it sounds really simple. It's going to help you so much later. If you can think about all of those in just being steps of each other. Okay. Now, some of you guys cheated on me and went ahead with the table, which is fine and wonderful and great. And you're already figuring out what I'm trying to get from you here. So I'm going to take my calculator. I'm in degrees. Uh-oh, that's not going to help me here. I'm going to go mode. Go to radians, and I'm going to hit enter to switch the mode to radians. And then you go second mode to get back to the screen. Okay, and I'm gonna say, all right, I'm gonna fill out this table. So sine of 0, what should that be? Sine of 0 degrees is 0. Sine of 0 radians is also 0. Okay, so you're gonna get this, and then you're gonna come over here and graph this coordinate at 0, 0. Okay, then you're gonna say sine of pi over 4. Pi is second exponent button, the caret button. It's right here. Oh, that looks familiar. What is that? That's our area code, which would be like here-ish. Okay, keep going. Oh, and by the way, I'm really a lazy human being, so I'll scroll up and hit enter and then change that to a 2. Supposed to be at the same spot. Okay, so I think I've got the pattern now. Okay, did my sine wave change at all? Did the heights change, the values? No, it's just the labels on the x-axis. This is 0. This is 360. This is 180, 90, 270, 45. Same exact thing, just different labels. Okay. We have one more thing to talk about though, real quick. I know I only have 1 minute of your time. Did you guys notice that we screwed up the stamp sheet? Did anybody notice that we screwed up the stamp sheet? Okay, real quick. This is a Monday. We don't do Monday quizzes. Your quiz is on Friday, not Monday. So what I need you to do is just go like this. That's it. No, I just did the. Oh my gosh.
Bye.
Bye, honey. I fixed it. I fixed it. It looks so much better now.